Hi everyone. This series of the purpose of these videos is for revision of statistics and specifically descriptive statistics, and it doesn't replace your lectures. Okay, so this is just for revision. So let's start with descriptive statistics. We know statistics is the science of collecting, organizing, summarizing, and analyzing data to make decision or draw conclusions. So the purpose of statistics is making rational decisions. So it helps to understand the reality and make decision based on data instead of just opinions. We have two different statistics. We have the descriptive that summarize and describe the data, and the inferential statistics that draw conclusion about a population from a sample. So let's see the case statistical terminology, definitions, and examples. So the first concept in statistics is the population. So it is actually the complete set of elements or individuals in this study. And a good example for this, imagine all students in university. This actually represents the population, all the students. Now the second concept is sample. A sample is a smaller group or a subset of population. It is a smaller group taken from this population. An example, from all those students, we choose randomly 100 students. This 100 students represent the sample. The third concept is statistical unit, is actually the single individual element or one individual element of the population. Here, in this population, the unit is one student. Finally, we have the variable, which is the characteristics that measured or observed on each unit. For example, age, gender, grade, income, etc., which means the characteristics that differ from a unit to another unit. Now let's see the types of statistical variables. Generally, statistical variables are broadly divided into two categories based on the nature of the data they represent. So we have qualitative, that are themselves divided into two types. The nominal, that the data here are usually described by words where the order doesn't matter, like it is without order, like gender, like color. Okay, and then we have the ordinal. Here the data are described by categories where there is a clear logical order of ranking. For example, the satisfaction level, we have the low level, medium, and high. Now the second type of statistical variable is the quantitative, which is which describe actually a quantity or an amount that can be measured or counted, unlike the qualitative that cannot be counted. So for the quantitative, also it is divided into two different types. That we have the discrete, which is numerical values that are distinct and countable gaps between them. So which means you can have 2 or 3 children but not 2.5, for example. Between one children and one children there is nothing. And we have continuous data, the numerical value that can take any value within a range and are usually obtained by measuring. So it can take any value, which means in a range between let's say between 1 and 2, there is an infinity of values inside. So this is what we call continuous variable. Example, height, income, age, weight, and many other examples. For example, here income. When we say income, um, like between 1 million and 2 million, there is an infinity of values. This is why we call it continuous. Unlike the discrete, between a value and the next value there is nothing, they are isolated. Now organizing and presenting data clearly is a crucial step in descriptive statistics, and a frequency table is the most fundamental method for organizing data. It summarizes a data set by showing classes or values depending on the nature. So here let's see for discrete how we organize the discrete data into a table. For example, here we have the number of children, which is our variable that changes from family to family. So here if I ask you where is the population, you can say all the families. The sample is some families from all those families, few of them. And what is the variable is the characteristic that change from a family to a family, because the family here is the unit, one family is there. So what differ in what the families differ from each other in number of children. So the number of children here is the variable. Now let's see the frequencies. 2 for 1. How to read this? It means we have 2 families that have 1 child. We have 4 families that have 2 children. We have 8 families that have 3 children, and so on. In the end, we have a total of 20 families. So 20 families is a sample of all the families from a city, for example. Now we have the relative frequency, which is the proportion of total data presented by each data value. How to find the relative frequency? So it is the frequency, like 2 for example here, divided by the total, we get 0.1. For this it is 8 divided by 20, so it is 0.04. Then we can find percentage by multiplying the relative frequency by 100. So here it is 40%, here it is 30%, and so on. The total is always 100%. And then we can use this, the relative frequency times 36, to find the degree of the angle from the pie chart. So we know that it is 360 degree. So for example, this one, the families that have 3 children represent actually 40%, and it takes 144 degree from a circle of 360. So this is useful when we want to draw the pie chart. Now once the data is summarized in a frequency table, we can choose a graph to visualize it. For discrete data, we use the bar chart. This one is the bar chart, a simple bar chart, and where the height represents the frequencies. For example, the family with 3 children, we have 8 family, the frequency is 8, so the height of this bar is the frequency. We can also draw the polygon. It is the same thing actually, where this point is like here, the families with 1 children. Okay, so the family with 1 children, we have 2, this is the frequency. Then with 2 children the frequency is 4, the 3 is 8, and then for 4 children the frequency is 6, then you link those points with straight line. This is a polygon. Then finally you can draw the pie chart here by using this relative frequency times 36 to find the degree of each value of the number of children. For example, the families with 3 children represents 40%, and in term of degree it is 144. Then you can draw the pie chart. So that's it for this video, and in the next one we talk about continuous data and cumulative frequencies. Thank you for watching.